We're going to use an interactive simulation just to demonstrate what the bubble and dew points are on both pressure, mole fraction, and temperature mole fraction diagrams. And the idea, if we look at a pressure mole fraction diagram, this is an ideal solution. High pressure is liquid, low pressure is vapor. Bubble point means as we raise the temperature at constant pressure, point where we first get a bubble of vapor, or if we lowered the pressure at constant temperature, the point where we get the first bubble of vapor. Dew point, which the green line in this graph is dew point. Dew point means the point where the first drop of liquid appears if we were to raise the pressure at constant temperature or lowered the temperature at constant pressure. Let's look at the simulation and identify numerical values for the bubble point and the dew points. So here we have the interactive simulation with a temperature 104 degrees C. And if you're interested in the bubble pressure, move this dot down until, if we watch the bar graph on the right, we get the first bubble of vapor. It shows mole fraction 0.81. That's a temperature then, 104 degrees C would be the bubble temperature at a pressure 1.5 bar, or at 104 degrees C, the bubble pressure would be 1.5 bar. So let's look at starting with vapor, and as we raise the pressure, just a point there where we see liquid forming. We haven't yet changed the mole fraction of vapor phase because now liquid to be formed is really small. Well, this would be the dew temperature would be 104 degrees C at a pressure of 0.83 bar. At 104 degrees C, the dew pressure would be 0.83 bar. Another way of looking at this is to fix a pressure. So let's move the dot to, say, a pressure 1.66 bar. So at this pressure, if we want the bubble temperature, I can raise the temperature until right there the first bit of vapor is forming at a temperature 108 degrees C. So that says at this pressure, the bubble temperature is 108 degrees C. Now, if I continue to raise the temperature, keeping the mole fraction constant right around here, temperature 130 degrees C, that would be the dew temperature at a pressure of 1.66 bar. So a couple different ways we can look at this. And we also could do the same thing on the TXY diagram. So on a TXY diagram, if we have this mole fraction and we fix the pressure at 1.66, then we could move the point at constant mole fraction until the point where we just have drop of liquid. That would be the dew temperature. And then now the bubble temperature would be right around there. So the idea of these lines, of course, on the temperature mole fraction diagram, the bubble temperature is the lower curve on the graph, the blue curve. It corresponds on a pressure diagram, pressure mole fraction diagram, it's the higher pressure.